For lesson 2, we get to wrestle with some formula work. We're going to derive our formulas for the volume of prisms and of cylinders, and then we're going to apply that thinking to do some actual calculations. All right, so you need to have a calculator for this. You need to know your formulas from lesson 0, and so have those handy, and that will benefit us greatly as we do this work. There's some key vocabulary here that I want to make sure that we know, building on the vocabulary from last time. A prism is one of those polyhedrons that we talked about last class that has 2 congruent parallel faces. A cylinder is likewise a 3-dimensional figure, but the bases are circles. So it's weird that we're calling these bases and faces, because when we're talking about a polyhedron, the faces are polygons, but a circle is not a polygon. So that's why when we're talking about these bases, these parallel faces, the faces that are congruent, or the bases that are congruent, are circles when we're talking about a cylinder. But for a prism, it can be really any kind of polygon. The goal here is to not differentiate prism from cylinder. There's some nuance with the vocabulary because circles aren't polygons, but we can still compute the volume the same exact way. And so I don't want us to think about maybe the 8th grade or 7th grade version of the formula for the rectangular prism or for the cylinder as if they're different things. Because by nature, they have more in common than you might think. All right, so I want to make sure that we're on the same page, that our formulas for prism and cylinder are essentially the same, with the exception that the area of their base is different computationally. All right, the lateral faces, those are the sides of the prism. That doesn't work for a cylinder. We don't have lateral faces for a cylinder, but we do have kind of that outside shape, and we'll break that down when we talk about surface area in a little bit. Altitude is that segment that connects the parallel faces of our prisms or our cylinders, and that is a perpendicular distance. It's perpendicular between those planes, and its length, the length of the altitude, is the height. So these are kind of sloppily used interchangeably. The height of the prism is the height of the prism, and so you don't need to really get into the nuance there. But what I do care about is that you are finding the perpendicular distance between the bases. All right, between the circular bases of the cylinder or the parallel congruent faces of the prism. All right, so keep that in mind as we try to understand these figures. When we're talking about prisms or cylinders, we have usually these pictures of these right prisms or cylinders where the bases are not only parallel to each other and congruent to each other, but they're right over each other. They're perpendicular to this segment, and this segment is standing perpendicular as one of the sides of the prism. You can have an oblique prism or an oblique cylinder where the bases are not directly over each other. And in this case, the height is found by measuring not a side or that lateral edge of your prism or cylinder. All right, so instead, that altitude falls outside of the figure. All right, if the altitude is on the figure, all right, then it's right. If it's not, then it's over here. Most of our work is going to be with these right prisms and right cylinders, so I don't stress about this too much. Just know that vocabulary. It doesn't hurt you to learn new words. All right, so fun fact though, if the figure is moved in more an oblique fashion, but has the same height, it doesn't affect the volume of that figure. This principle here just states that if these figures have the same height and the same cross-sectional area, if the area of this square is the same as the area of this triangle is the same as the area of that circle, and they're all the same height, then all of those volumes will be equal. And the reason for that is rooted in the way that we calculate the volume, all right? And so what this means for us is the area of this base, whatever that base is, multiplied by the height, if we were to stack a lot of those rectangles one on top of another, or the area of this base, this circle, and I were to stack those circles one on top of the other until I reached to that perfect height, that would be how we would calculate the volume, is the area of the base times the height. The area of the base times the height. Now this is a capital B, and this is a little h, and that means this capital B is referring to the area of the base. This doesn't say base times height. It says the area of the base times the height. And so I know that we're familiar with the area of a rectangle or of a parallelogram being little b times h. And that's not wrong, all right? But this base has a base, and this base has a height. That is not necessarily the height of the prism. And so this can get a little bit muddy if we say, oh, this is base times height times height. It's like, well, which height are you talking about? The height of the base or the height of the solid? And so that's why our language can get a little bit messy. And so we say that our volume is going to be found by taking capital B times h, all right? The area of the base times the height. And here's what's interesting. The volume for every prism, regardless of if the prism is a triangular prism or a rectangular prism or a hexagonal prism, is going to be the same calculation, right? The same formula for the volume for a cylinder, which is the area of the base. It's a different calculation, pi r squared, all right? And then times the height instead of base times height and then times the height, or length times width and then times the height, or then base times height divided by 2 and then times the height, or area is 1/2 apotheta times perimeter and then times the height. So we have all those other formulae that we have to kind of keep in balance. We have to know that this formula is referring to the area of the base times that perpendicular distance between those bases, all right? That is the volume formula. And so now we're going to use that to do a few things. I have a little note here to be careful with triangles because we know that triangles kind of get us here and there. The volume is found by taking the area of the base times the height. Now, one of the things that we learned about prisms is that any of the faces in a rectangular prism could be the base. Most of us, however, are going to refer to the bottom as the base, and it doesn't have to be that way, but most of us are going to do it that way. So the area of our base here is going to be 4 times 3, and our height then is 5. And so this, you might remember the middle school formula, length times width times height, and that's not wrong, but if you're engaging with this content in that way, you are missing the point. You are missing the point of this instruction that this is our formula, the area of the base times the height. That we don't have to remember a new formula when you get to this, or when you get to a hexagonal prism or something like that. All right, so this gives us 12 times 5, which is 60. We have units, and the units times the units times the units means the units are cubed. All right, over here, the base, what are the bases? The bases are triangles. This is a triangular prism. So here, the bottom is not the base. All right, that rectangle is not the base of this triangular prism. All right, so don't do that wrong. The volume is found by taking the area of the base times the height. Well, the area of our base is going to be 1/2 times the base of the triangle, 6, times the height of that triangle. I do not know the height of that triangle by looking at this. But lucky for us, we have tools to find that height. If I draw in this isosceles triangle, if I draw that altitude, it cuts my 6 into 3 inches and 3 inches, which means I get 5 squared minus 3 squared gives me the height is 4 squared. So my height is 4. You might need to do that work off to the side. If we have like 30, 60, 90 rules, then maybe there is a shortcut that we could take to make sure that we can do this well, make this happen, and have success with it. But the height is going to be 4 inches. But now I need to multiply that by the height of this, this triangular prism. Okay, so the height, again, is the perpendicular distance, 12 inches, between those parallel congruent faces. So here I get half of 24 is 12. 12 times 12 is 144 cubic inches. All right, how did you do that? Be careful with the triangles. Be careful with bases. Base doesn't mean bottom. Over here, the circles are our bases. The circles are our bases. All right, so we're going to find the volume by taking the area of the base times the height. You get to do that one. I'll do this tough one. Why is this tough? If the diameter is 7, that means the radius is 7/2. Womp womp, we got to deal with decimals. We don't want decimals, we're working in terms of pi, so no decimals. The volume is the area of the base times the height. The volume is pi times the radius squared, and then times the height, which here is 10. The height is 10 because it is the perpendicular distance in this right cylinder, the perpendicular distance between those parallel congruent faces, circular faces. So this gives us 49 pi over 4, and then that's being multiplied by 10. So I can cancel out one of the 2's there. I got to do 49 times 5. which is, I might maybe need to use a calculator there. So it would be 250 minus 5, 245 pi over 2. Hopefully I did that right. Centimeters cubed. But now you guys are making me second guess myself, so let's make sure that I can take 49 divided by 4 times 10, and then change that into 245 over 2. Hey, I did my math right. Okay, good. So hopefully there you're able to execute the volume for a cylinder, finding the area of the circle, and then multiplying it by the height. Please, please, please do yourself this favor and understand that volume is the area of the base times the height. Don't think of this as, oh, well, this is pi r squared times h, and the other one was 1/2 base times height, and the other one was base times height, or length times width times height. Don't miss the boat here, all right? Engage with this at a high school level. Understand we're finding the area of the base, which we practiced at length in lesson 0, times the height. If you can identify the base, then you can find its area, and then multiply it by that perpendicular distance. Hopefully you did a good job on this, and you are hopefully done with your notes. Please let me know what questions, if any, you have.